is given the next information. In this question, you will investigate series of the form sum for I from 1 to n of I to the power of q, which is 1 to the power of q plus 2 to the power of q plus so on up to n to the power of q, where n and q are positive integers, and use various methods to find polynomials in terms of n for such series. When q is 1, the above series is arithmetic. A shows that the sum for I from 1 to n of y is half multiplied by n plus 1. So we should consider q is 1, and the given series becomes sum for I from 1 to n of I to the power of 1, which is just I, and it becomes 1 plus 2 plus 3 plus so on up to n. And we can see that there are n terms. The first term is 1, and applying a formula for the sum of the first n terms for the arithmetic series, this formula is Sn is u1 plus un, the first term, plus the nth term divided by 2 multiplied by n. But be aware, because this n and this n may be different. For example, if sum is from 0, not from 1, there will be n plus 1 terms. So here there are n terms, so n is n and u1 is 1, so it becomes 1 plus n over 2 multiplied by 1, which is a half multiplied by n plus 1 as required. Consider the case when q is 2. B. The following table gives values of n squared and the sum for I from 1 to n of I squared for n is 1, 2, 3. And it is given the next n squared and sum for I from 1 to n of I squared. When n is 1, n squared is just 1 squared 1, and the sum becomes the sum for I is 1 to 1 of I squared, so it's just 1 squared, and it is given that it's just 1, and it is given that when n is 2, n squared is 4, and the sum is 5. It's because it becomes sum for I from 1 to 2 of I squared, and it becomes 1 squared plus 2 squared is 5. And when n is 3, n squared is 9, and it's p, and write down the value of p, 1 mark, and it's the sum for I is from 1 to 3 of I squared, so it becomes 1 squared plus 2 squared plus 3 squared, which is 14. So p is 14. The next, the sum of the first n square numbers can be expressed as a cubic polynomial with 3 terms. So we should consider the sum for I from 1 to n over I squared, and it is given that the sum is a1n plus a2n squared plus a3n cubed, where a1, a2, a3 are q plus. What does it mean? It means that they are positive and rational. Rational, it means that they can be represented as a fraction. And hence write down a system of 3 linear equations in a1, a2 and a3, 3 marks. a1, a2, a3. So To get the required three equations, we can use this information. So when n is 1, the sum is 1. So a1, and just substituting 1 for n, we get a1 plus a2 plus a3 is 1. The sum is 1. And when n is 2, it becomes a1 multiplied by 2, so 2a1 plus 2 squared 4a2 plus n cubed, so it becomes 8a3 is 5, and when n is 3, it becomes 3a1 plus 9a2 plus 27a3 is 14. And we need to solve for a1, a2, a3. There are only 2 marks, and definitely it is suggested to use a calculator, but let me show how to solve it without a calculator. To solve and in general to consider a system of 3 equations, and there are such questions which are related to planes, and also it's required to consider such system without a calculator. So let's consider it, and we should write the augmented matrix, and it looks like this. We just write coefficients 1, 1, 1, and this value 1, and 2, 4, 8, 5, 3, 9, 27, 14. And if we add or subtract any, if we consider any row plus or minus any combination of another row, we get an equivalent system. What do I mean? For example, if it is given to x plus 3y is 10 and x minus 2y is 5, and for example, if we consider row 1 plus row 2 and consider 2x plus 3y is 10 and 3x plus y is 15, so it will be an equivalent system. We check, yes, it's correct. So the method is the next. We do 0 here, and we can see that we can consider row 2 minus 2 times row 1, so it becomes the first row remains the same, the second row becomes 0, 2, 6, 3. It's just 2 minus 2 multiplied by 1 is 0, 4 minus 2 multiplied by 1 is 4 minus 2 is 2, and 8 minus 2 multiplied by 1 is 6, and also 5 minus 2 multiplied by 1 is 3. And then we make 0 here, and we can consider row 3 minus 3 times row 1, so it becomes 0, 9 minus 3 is 6, and 27 minus 1 multiplied by 3 it's 24, and 14 minus 3 is 11. And then we make 0 here, and we can see that we can do what? Row 3 minus 3 times row 2, and the first row remains the same, the second 0, 2, 6, 3 also remains the same, and the third becomes 0, 0, 24 minus 6 multiplied by 3 is 6, and 11 minus 3 times 3 it's 2. And what does it mean? It means that 6a3 is 2, so a3 is 1/3, and the second row becomes 2a2 plus 6a3 is 3, and we can substitute 6a we can substitute 2 for 6a3 directly, so it becomes 2a2 plus 2a3. So 2a2 is 1, so a2 is a half, and the first row a1 plus a2 plus a3 is 1, so a1 is 1 minus a2 minus a3 is 1 minus a half minus 1/3. 6 is the common denominator, so it becomes 6 minus 3 minus 2, so it's 1/6. But it's not required here. Definitely you should solve it with the calculated for 2 marks. And how to do that? You should choose matrix, edit, enter, and you enter coefficients, and you should consider 3 rows for columns, and you enter coefficients in front of a1 here, a2 here, a3 here, and values these 1, 5, 14 are the fourth column. So the first row becomes 1, 1, 1, 1. The second row is 2, 4, 8, 5, and the third row is 3, 9, 27, and 14. Then we choose second matrix mass, and we choose this RREF, enter. Then second matrix names A, because our matrix is A, and just enter. And this column is gives us the required values, and just mass fraction, and we can see that we get the required values 1/6, it's a1 half and 1/3. The next you will now consider a method that can be generalized for all values of q. Consider the function f of x is 1 plus x squared plus so on up to x to the power of n is positive integer. C shows that x multiplied by the derivative of f is x plus 2x squared plus 3x cubed plus so on up to n multiplied by x to the power of n. 1 mark. So x multiplied by the derivative of f becomes x multiplied by, what is the derivative of a given function? Derivative of 1 is 0, derivative of x is 1 plus x squared derivative is 2x plus the next term is x cubed, and its derivative is 3x squared plus so on up to n multiplied by x to the power n minus 1. And if we multiply by x, we get x plus 2x squared plus 3x cubed plus so on up to n x to the power of n as required. Let f1 of x be x multiplied by the derivative of f, and consider the following family of functions. f2 of x is x f1 derivative of x, f3 of x is x f2 derivative of x, and so on. And in general, fq of x is x fq minus 1 derivative of x. Di shows that f2 of x is the sum for I from 1 to n of I squared multiplied by x to the power of I, 2 marks. So we should consider f2. What is f2? It's x f1 derivative, and what is f1? It's x f derivative, and it's actually the result. So it's x f1 derivative so it's x plus 2x squared plus so on up to nx to the power of n derivative, which is x multiplied by 1 plus 2 squared x plus so on up to n squared x to the power of n minus 1, and if we multiply by x we get x plus 2 squared x squared plus so on up to plus n squared x to the power of n, and in front of x we can write that it's 1 or 1 squared, and in general it becomes the sum for I from 1 to n I to the I squared and x to the power of I. Or we can consider in general using sigma notation, it's it's the sum for I from 1 to n I x to the power of I. So we can see when I is 1 it becomes just x, when I is 2 it's 2x squared and so on, and then f2 becomes x f1 derivative, so it becomes this sum derivative, and it becomes x, the sum I, it's a constant, and derivative of x to the power of I, it's I x to the power of I minus 1, and it becomes the sum for I from 1 to n I squared x to the power of a minus 1 multiplied by x, it's x to the power of I as required. The next prove by mathematical induction that fq of x is the sum for I from 1 to n I to the power of q x to the power of I. Q is positive integer, 6 marks. So as usual we write for q. Notice that in general when it's a problem on the mathematical induction we use n as a value which changes, but here n is some constant parameter, but we should consider everything with respect to q. Q changes here. So q is positive integer, so the first possible value of q is 1, and we consider for q is 1, it becomes f1 of x, and what is f1 of x? It's x f prime of x, f derivative of x, and it's let's use sigma notation, so it's the sum for I from 1 to n of I x to the power of I x to the power of I, it's from I, and from the statement for q is 1, it becomes f1 of x, it's the sum for I from 1 to n, I to the power of 1 x to the power of I, which is the same, so true for q is 1. The next step is as usual, where I assume true for q is k, and it becomes fk of x is the sum for I from 1 to n, I to the power of k x to the power of I. And the next step is we consider for q is k plus 1, and we consider fk plus 1 of x, and what is fk plus 1? According to this pattern, we can see that the next it's the previous derivative multiplied by x, so it's x f, the previous is fk, so it's fk derivative of x, so it becomes x, and the sum for I from 1 to n, I to the power of k x to the power of I derivative, which is x, the sum I to the power of k, it's a constant, and I x to the power of I minus 1, and it becomes the sum I to the power of k plus 1 x to the power of I. And let's compare. When q is k plus 1, it must be I to the power of k plus 1 x to the power of I, so we can see that it's true, so it's true for q is k plus 1, and that's all, and we write conclusion as usual. If true for q is k, true for q is k plus 1. Since true for q is 1, true for any q is positive integer. And the next, using sigma notation, write down an expression for fq of 1. Notice that of 1, it means we should substitute 1 for x, so it becomes the sum for I from 1 to n, and it's I to the power of q multiplied by 1 to the power of I, which is just 1, so it just I to the power of q, and it is given, use sigma notation, write down an expression for fq of 1 mark. So that's all for this question. Then next, by considering f of x is 1 plus x plus x squared plus so on up to x to the power of n as a geometric series, shows that f of x is x to the power n plus 1 minus 1 divided by x minus 1. So since it's a geometric series, we just apply a formula for the first n terms of the geometric series, but be aware, because formula we use n in formula and n here, but they may be a bit different in general. So the sum of the first n terms, it's u1 ratio to the power of n minus 1 divided by ratio minus 1, and it's the sum of the first n terms. But notice that there are n plus 1 terms here, and actually we should consider the sum of n plus 1 as the sum of the first n plus 1 terms, or you may use in general sk as the sum of the first k terms, and here k is n plus 1. And the first term is 1, so it becomes according to the formula u1, it's 1, the first term. Then a ratio it's x, common ratio it's x to the power of n, but n, it means the number of terms, and here there are n plus 1 terms, so it must be n plus 1 minus 1, and the ratio minus 1, ratio it's x minus 1, so it's x to the power n plus 1 minus 1, x minus 1 as required. F for x is not 1, shows that f1 of x is equal to a given expression, 3 marks. So we should consider f1 of x, and what is f1 of x? It's from this part. f1 of x, it's x f derivative of x. So it becomes x f prime of x and x multiplied by, and we should consider the derivative of this function, and we can see the division, so we should apply quotient rule. So it's the denominator squared, numerator derivative. This formula is given in a data booklet, multiplied by the denominator minus just the numerator multiplied by the derivative of the denominator, and it becomes x minus 1 squared, it's in the denominator, x n plus 1 minus 1 derivative, so it's just x to n plus 1 derivative, it's n plus 1 x to the power of n minus 1 derivative, which is 0, multiplied by x minus 1 minus x minus 1 derivative is just 1, so it's minus x plus 1 minus 1 in parentheses. And we need simplify it to get an expression as required, and it becomes x minus 1 squared n plus 1 x to the power n plus 1 minus n plus 1 x to the power n, just expand these parentheses, minus x to the power n plus 1 plus 1. And it is equal to x minus 1 squared. Expand this expression, so it's n x to n plus 1 and plus x to the power n plus 1 minus this x to n plus 1, which is 0, and minus n plus 1 x to the power n plus 1, and just multiply by each term by this x, we get n x to the power n plus 2 minus n plus 1 x to the power n plus 1 plus x over x minus 1 squared, and let's check n x n plus 2 minus n plus 1 x n plus 1 plus x divided by x minus 1 squared. So it's correct, it's as required. G. I shows that limit x tends to 1 of f1 of x is in indeterminate form. It means it should be 0 over 0 or infinity over infinity. And what is f1 of x? It's this result. So we just substitute 1 for x, and we get that it becomes n minus, let's expand it, minus n minus 1 plus 1 divided by 1 minus 1 squared. So it's a 0 over 0, and it's in indeterminate form as required. 1 mark. And the next, hence by applying L'Hopital's rule, shows that given limit is a half multiplied by n multiplied by n plus 1. 5 marks. So we need just calculate limit when x tends to 1 over this function f1 over x, and since it's 0 over 0, we apply the L'Hopital's rule, and it says that this limit is given to limit x tends to 1 derivative of the numerator divided by the derivative of the denominator. So we should consider the derivative of the numerator separately, and it becomes n plus 2 x n plus 1 minus n plus 1 n plus 1, which is n plus 1 squared x to the power of n plus 1 divided by 2 x minus 1, and we just substitute 1 for x, and we can see that it becomes divided by 0, and it seems to be 0 over 0 again, but let's show it clearly. So it becomes n plus 2 multiplied by 1 minus n plus 2 squared plus 1 divided by 0. Why do we need to show that it's 0 over 0? It's because it will be again in indeterminate form, and we can apply the L'Hopital's rule again. Otherwise, if you get some value which is not 0 divided by 0, limit doesn't exist, and this limit is infinity actually. So it becomes n squared plus 2n minus n squared minus 2n minus 1 plus 1 over 0. So it's 0 over 0, and we apply the L'Hopital's rule again. So we consider the derivative of the numerator, and it becomes n plus 2 multiplied by n plus 1 x to the power of n minus n plus 1 squared x to the power of n minus 1 plus 0 divided by 2, and x minus 1 derivative just 1, so just divided by 2, and We substitute 1 for x again, so it becomes n plus 1, n plus 2, minus n plus 1 squared divided by 2, and it is equal to, and we can see that it's not 0 over 0, so we can calculate it, and we can see that we can factor out n and n plus 1, and it becomes n plus 2 minus n plus 1 in parentheses, or minus n minus 1, so it becomes n plus 1 multiplied by 1 and divided by 2, and we can see that we get the result as required. And that's all for this question.